The segment store maintains ordered sequences of immutable data blocks. Each segment is assigned a monotonically increasing identifier upon creation. Segments are stored in a directory structure keyed by their identifiers. When a segment reaches a configured maximum size threshold, a new segment is created and the write pointer advances. Closed segments are never modified. The active segment accepts append operations. All segments remain accessible for read operations regardless of their state. Index structures maintain mappings, from logical offsets to physical byte positions within segments. The offset index is stored alongside each segment and contains fixed width entries. Each entry maps a relative offset number to a byte position. Entries are written sequentially as data is appended. The time index stores timestamp to offset mappings for temporal range queries. Both indices are memory mapped for efficient random access. Index files use a sparse encoding to reduce memory overhead. Segment recovery proceeds through log file scanning. Upon initialization, the system scans the segment directory to identify all stored segments. For each segment, the index files are validated by computing checksums. If a segment index is corrupted, it is reconstructed by replaying the segment file sequentially. The reconstruction process reads each record and rebuilds the index mapping. Segments with invalid checksums at the file level are marked as unreadable. Recovery completes when all valid segments are loaded into memory. Record encoding uses a fixed header followed by variable length payload data. The header contains a magic byte, record type identifier, timestamp, and payload length. The magic byte serves as a synchronization marker during recovery. The record type field indicates whether the record is a data record or control record. Timestamps are stored as 64-bit Unix milliseconds. The payload length field specifies the number of bytes following the header. Padding is not used. Records are stored contiguously. The write buffer accumulates records before they are flushed to the active segment. Records are appended to the buffer in submission order. When the buffer reaches a threshold size or a timeout expires, a flush operation is triggered. During flush, the entire buffer is written as a contiguous block to the segment file. The segment file is then fsynced to ensure durability. After successful flush, the buffer is cleared and index entries are updated. Flush operations block new append requests. Read path resolution begins with offset lookup. The offset index is searched using binary search to find the segment and byte position containing the requested offset. If the offset falls within the write buffer, the buffer is searched directly. If the offset is in a closed segment, the memory-mapped index file is queried. The binary search operates on sorted index entries and returns the entry with the largest offset less than or equal to the target. The returned position specifies where to begin reading the record. Compaction processes multiple segments into a single consolidated segment. Compaction is triggered when the number of segments exceeds a threshold or when space reclamation is needed. The compaction process reads records from source segments sequentially. Records are validated as they are read. Valid records are written to a temporary segment file. Deleted or tombstone records are skipped during compaction. Once all source records are processed, the temporary segment replaces the source segments. The operation is atomic at the segment level. Tombstone records mark deleted entries without removing data immediately. When a delete operation is requested, a tombstone record is appended to the active segment. The tombstone contains the key and a deletion timestamp. During reads, if a tombstone is encountered after the target record, the record is treated as deleted. Tombstones are purged during compaction when the retention period has elapsed. The tombstone retention period is configurable and defaults to 7 days. Compaction removes all tombstones older than the retention threshold. Range queries use the time index to identify candidate segments efficiently. The time index maps timestamps to offset ranges. A range query specifies a minimum and maximum timestamp. The index is searched to find all segments with records in the timestamp range. Once segments are identified, the offset index within each segment is used to find the starting position. Records are then scanned sequentially from the starting position until the maximum timestamp is exceeded. Range queries return results in timestamp order. Segment rolling occurs automatically when the active segment reaches maximum size. The active segment is closed and marked read-only. A new segment is created with the next sequential identifier. The write pointer is moved to the new segment. The closed segment becomes eligible for indexing and compaction operations. Segment rolling happens transparently during append operations. If an append operation would exceed the size threshold, rolling occurs before the append is processed. Segment size is configured at initialization and cannot be changed per segment. Snapshot operations capture the current state of all segments. A snapshot records the segment identifiers, byte offsets, and timestamps of the last flush data. Snapshots are stored in a separate metadata file with a monotonically increasing version number. Snapshot creation is triggered periodically or on demand. During snapshot creation, the write buffer is flushed to ensure consistency. The snapshot file is written atomically. Snapshots enable recovery to resume from a known good state without replaying all data. Retention policies automatically delete old segments. The retention period is specified in days or by maximum size limit. Segments older than the retention period are marked for deletion. Segments are physically removed asynchronously after they are closed and no active read operations reference them. The system maintains a reference count for each segment tracking open readers. Segment deletion is deferred until the reference count reaches 0. Retention checks occur during compaction and periodically during idle time. Compression algorithms are applied during compaction to reduce storage size. Available compression methods include gzip, snappy, and lz4. Compression is applied per record or per segment depending on configuration. Compressed records include a compression type field in the header. During read operations, the compression type is inspected and decompression is applied automatically. Compression adds CPU overhead but reduces I/O bandwidth. The compression method is specified at store initialization and applies to all future writes. Concurrent access is managed through read-write locks at the segment level. Multiple readers can hold read locks simultaneously on the same segment. Write operations acquire exclusive locks on the active segment. Closed segments use read-only locks that never conflict. Lock acquisition follows a fair ordering to prevent writer starvation. The lock manager tracks all active locks and wake-up dependencies. Deadlock detection is not performed. Lock hierarchy is enforced by design. Timeout mechanisms exist for lock acquisition to prevent indefinite waits. Error handling follows a propagation model for all operations. Read errors on closed segments are returned to the caller with error codes. Write errors cause the active segment to be closed and a new segment created. Corruption detected during recovery leaves segments marked as unreadable, but does not halt initialization. Index corruption is repaired automatically through reconstruction. Checksums are verified during all file operations. Errors are logged with full context for debugging. The system continues operation in degraded mode if segments become unavailable. Configuration parameters control segment behavior at initialization. Maximum segment size is specified in megabytes and defaults to 1024. Flush timeout is specified in milliseconds and defaults to 5000. Retention period is specified in days and defaults to 7. Compression method defaults to none. Buffer size is specified in kilobytes and defaults to 64. Thread pool size for compaction defaults to 2 workers. Lock timeout is specified in seconds and defaults to 30. All parameters are immutable after initialization completes.